Hello again, everyone. In this lecture, we'll discuss about a different type of transmission or communication channel. A transmission or communication channel are the means through which your message passes from the sender and reach the receiver side. I mean, from one machine to another machine. There are two types of communication channel here, which is the wireless and the wired communication channel. We'll discuss with the first one in today's lecture. So your wireless communication, fine. This is where you transmit the message from the source to the destination without using any wired connection. I mean, just with the help of a signal, your message will be transmitted from one machine to another machine. So clearly, before we start with the different type of wireless communication supported, you need to understand first few of the term and few of the concepts that are commonly used in your wireless communication. We'll start with the first one here. This here is your antenna. Fine, antenna will be attached always, okay, in both the source and the destination when you are communicating it using your wireless communication. Now your antenna will always do two things. It'll always act as a receiver and receive the incoming message, and at the same time it can also be used as a transmitter. I mean to transmit a message from here, from the source to the destination. That is the first thing that you need to remember. So whenever an antenna have to be used, it have to be properly aligned so that the incoming message reaches the antenna, and likewise it has to be aligned properly in such way that the message that goes out from here have to reach its destination. Okay, so that is your antenna. Next, you have concept called as omnidirectional and unidirectional. And we will explain this with help of this example. Now consider this to be the sender. This is that mean where your signal emits. This is where you want to send a message. Now in the first case here, in omnidirectional means in all direction. What happens when a message is transmitted from here? This message will be transmitted to all the direction. So whether the receiver is here or here or here or here, okay, it doesn't matter. The receiver will always receive the message. So in this case, your antenna can be anywhere. Fine, you don't have to align it in a specific way to receive the signal. You can just place it anywhere in this, within this radius. Then your antenna will receive the message. Whereas in the second case here, what you have is you have the signal. This is say the source. This is where your sender will be sending the message. Now when the signal comes out of this source, this signal will travel in a straight line. So that is why we also call this as a unidirectional or straight line or a point-to-point communication. So when it travels in a straight line, you have to be very careful that whoever wants to receive this message, they have to be exactly aligned in the same line as that of the source. Fine, so it have to be here. Otherwise, if you place this antenna, that means the antenna of this receiver here or elsewhere, this receiver will not receive the message. So that will be regarding the alignment. In omnidirectional, you can place your signal anywhere, you can place your receiver anywhere, it will always receive the message. But as in case of your point to point, we call this point to point because we are sending it from one point and it reaches exactly one point. So in point to point communication, what happens is your antenna here has to be properly aligned so that the signal will reach its destination. Okay, so we'll start with the first type of wireless communication, which is the infrared communication. For you to clearly understand, remember what is this infrared communication, we'll take the example or the application where your infrared signal is actually used. So infrared communication or infrared signal is the signal that comes out from your remote control when you try to control your television set. Fine. So that will be the example of where your infrared signal is being used. So now, okay, think about your remote control and your television set. Now this signal will be transmitted only within a short distance. If you're very far away from your television set, you will not be able to use your remote control. Likewise, your remote control have to be properly aligned with your television set. And you cannot just place it randomly in any direction and control your television set. Fine, you'll have to place it correctly in a proper alignment with your television set so that you'll be able to control it. Likewise, if you are say in a different room and your television set in a different room, you cannot use your remote control from the other room to control the television set that is in another room. The reason being which your infrared signal cannot pass through any solid object. It cannot pass through walls. Right? So if you have to, there should not be anything in between. That means your remote control and your television set. If there's something in between, your signal will not reach the television set. Right? Now the advantage of using an infrared communication is that there will be less interference from any outside signal. If there are other signal outside your room, right, outside the room where your television set is kept, those outside signal will not interfere with your dish signal. The reason being which what happens is, yeah, this infrared signal will not go outside this room. It will be available only with this room. I mean, when you click on it and then pass whatever message you need to pass to your television set. So that will be your infrared signal. Second one here is the radio technology. Application of the radio signal are those different signal that you get in your radio channel. Fine, say for example your 93.5 Red FM. That is one of the example of your radio signal. That are in your radio signal. This here is used to cover a very long distance. That means you can transmit this signal from one distance to a very far away, from one place, I mean to some very far away place. It covers a longer distance. Data here can be transmitted in a specified frequency range only. Say if you need your Red FM, it have to always be 93.5. Fine. That is a specific frequency for the FM that is specifically allotted to that particular signal. So likewise for different channel, different frequency range will be allotted to them. This signal can pass through solid object. That is why you don't have to keep your radio set outside the house. You keep it indoors, your signal will definitely reach the radio set. That means it can pass through solid object and it can pass through walls and everything. It is omnidirectional. That means no matter where your radio station is available, you can always receive the message for as long as you are within the coverage area. The signal emitted from the radio channel here, the radio station, will be transmitted in all the direction. Okay. So it can be used both in outdoor and indoors. Next one here is your microwave signal. Right. The example of where a microwave signal is used is in your television, is in your dish connection, your Airtel, say your Tata Sky connection, your dish connection. Now in a dish connection, what you have here is, say, this is the earth, consider this around, this is the earth, and then your receiver and your sender, I mean the sender who will be, that mean the actual channel who will be sending the connection. Fine. The service provider for your Tata Sky connection, see, they are located somewhere here, whereas you are located here. Now in case of a microwave signal also travel in a straight line. So here what happen is, if you look at this, the sender is in one location, whereas the receiver is another location. Now what happen if I have to pass a signal, I cannot bend this signal through the curvature of the earth, right? Because the earth is down here. So what I'll do here is, since my signal have to travel in a straight line, this is what I'm going to do. I'm going to set up a tower. That is why tower is being set up in different location, right? In the cities or in like different geographical area. You have a tower. And now on top of this tower somewhere, we will place the antenna. Now what will happen if the sender want to send a message? From here, the sender will send a message, and okay, the signal will transmit in a straight line and it will reach the antenna. Once the antenna receives this message, the antenna in turn will transmit this message to the receiver, which is located here. So though, fine, the receiver and the sender are located different part of the earth. See, you can always transmit it with the help of a tower. So a tower normally are very long, right? They are very high, so that you will be able to actually send a message from one place to another place. So this is how you get your dish TV or your dish connection. Fine. Well, from here the message will be transmitted with the help of a tower. From the tower, then it'll reach to you. Now this is what we have. In case of your microwave signal, this can be transmitted at a very high frequency signal. I mean, it can be transmitted at a very fast speed. Your Tata Sky connection is weather dependent, right? Or any of the Dish TV connection is weather dependent. That is why when it is raining heavily or when it's too cloudy outside, what happens is you will not get any signal in your dish connection. Like what I've already mentioned, it cannot bend with the curvature of the earth, so that is why you need the tower. It uses a point-to-point communication. I mean, it travels in a straight line. It does not propagate through solid object. That is why your dish antenna will always have to be somewhere outside, normally in the rooftop, right? So that it receives the signal, and from there, the signal then will be passed to your television set. Right? Antenna have to be accurately aligned. That means they have to be aligned exactly in that straight line so that it receives the signal, and at the same time, it should be able to transmit the signal to the sender. The last one here is the satellite communication. The satellite communication is also commonly known as the SATCOM. SAT for satellite, COM for communication. So here we use a satellite for transmitting the data. Right? Sometimes what happens is you cannot just go and set up tower, right? In each and every, suppose if there's an ocean in between. If there's an ocean between your sender and the receiver, it will be very difficult for you to set up a tower in the ocean. So what we'll do is, rather than going through all that, we will set up an antenna somewhere in the space. Fine. So an antenna will be in the space. From one part of the earth will send the signal to the satellite, and from the satellite, okay, it again be forwarded back to other part of the earth. So that means here both the sender and the receiver will be in the earth. That means consists of both the earth station on both ends, the receiver and the sender as well. But now your satellite communication is very expensive. Just an organization, a small organization cannot set up their own satellite, right? So it's normally is the government who spends on satellite so that everyone can use the satellite that has been launched. And so it is very expensive. And what we have to keep in mind is that the satellite here, the speed of satellite, have to synchronize with the speed of the earth. That means your satellite also have to move exactly the same speed as that of the earth, so that your satellite can move together with the earth. It will not move slower, it will not move faster than the earth, but it will rotate at exactly the same time as that of the earth. Okay, so these are the 4 types of your wireless communication that you can use to transmit data from the source to the destination. That means from one machine to another machine. There are many different types of wireless communication. Example of which is your Bluetooth connection, right? And your Wi-Fi connection, for example, those are also part of your wireless connection, but which is not included in your syllabus. Now, few of the advantage and disadvantage of using a wireless connection is that, okay, we'll start with the advantage first. Advantage of using this is that it is easy to install, and you don't have to have a wired connection. You don't have to have a fixed topology, no star topology, no tree topology, no ring topology. And you can set it up in any form. You just have a signal, you place your devices anywhere, it doesn't matter. Transmission speed is very fast. Okay, transmitting data from one device to another device is very fast. And then there is also flexibility for user to move around. When you have a wired connection, what happens, wherever your cable is connected, you have to stay fixed in that same place, right? Whereas if you use your mobile phone nowadays, which is a wireless connection, you can just move around along with your mobile phone. The main disadvantage part of using a wireless connection is that it is less secure. That is why what happens is people steal cable connection, right? You must have thought of all that, for example. And then other than that, what happens is, if you log in your Wi-Fi connection, you will always see that there are so many other Wi-Fi that is already available. Okay, so that becomes less secure. Everyone can just easily detect the signal. It can easily be affected by outside interference, like your infrared signal. When you cannot use it outside, it will interfere with the signal of the sun. Your microwave signal, it interfere with the weather, right? So that is the disadvantage of using a wireless connection. We'll stop here for today. We'll continue with the wired connection in the next lecture. Thank you very much.